writing. Shankardeep, you can write here, right? Okay. Okay. So, hello everyone. Can all of you hear me? The audience, if you can hear me, please let us know because we will be starting the IOQM. Okay, it's
So should I send the Google like the YouTube link on Cheenta Commons so the people can see?
yeah. The YouTube link is shared already.
Sir, actually I can't see it on Cheenta Commons.
Okay, you can maybe post it there. That's fine. Yes. Okay, hello everyone. If you can hear us, okay. So I see some people. Someone just said, "Yes, we can hear you." So that's great. So wait
I've
for.
shared the link.
Okay, okay. So this is great. So okay. So we can start, and I don't think Kanish can. Shorodip, okay, Shorodip is here, so I have added him to stream. Hello, Shorodip. Kanish, I cannot hear you or see you, so I'm not adding you to stream yet. Let me know when you are in, then I will definitely add you. Okay, so okay, so we will be discussing the problems from IOQM 2021. And today we have with us Shankardeep, who is a faculty at Cheenta. My name is Ashwini Dashgupta. I'm also a faculty at Cheenta. We have Arjun and Shauradip. Arjun and Shauradip are students who gave IOQM this year. So this will be a very nice opportunity for all of us to collaborate and do some good mathematics. Now, Shauradip and for Arjun, there was a question number 27, which seems like everyone had a little problem with that. So could you solve 27, number 27?
Sir, actually during the paper I got the right idea. I think, but the main mistake I did was one point was a minus 3 comma 2 and the other point was b 3 comma minus 2. But I took b to be 3 comma 2. So there was a minus mistake. So my
Okay,
answer got wrong. But actually Shrejit sir has told the answer on the group, so he has most probably solved it.
okay. So let's talk about problem number 27, Shankadeep as well. So Shankadeep, Shauradip, you can also comment here. It's a very beautiful problem actually. It says that there is a point A whose coordinate is given to be negative 3 comma 2, and there is a point B whose coordinate is given to be 3 comma negative 2. Okay, so these 2 points are there. Now what we want to do is there is a bug at the point A. There is a bug at the point A. So if you're not speaking, you can keep the audio muted to remove background noise. Thank you. Okay, so there is a bug at the point A, and the bug wants to go to the point B. It wants to start at A, and it wants to go to the point B. And the way it wants to do this is like this. It will follow something called a taxi cab metric. So this is a geometry and combinatorics problem, this problem number 27, IOQM, and it uses something called the taxicab metric. Now, if you have not seen the taxicab metric before, it's very simple actually. What you do is you either go left or right, or you go up or down. So you are not allowed to go diagonally. So this is, yeah, it's good if someone else completes the picture, that would be great as well. So yeah, this is the point 0 comma 0. That's awesome. So there is a fantastic book called Taxicab Geometry, which deals with problems related to this. So anyway, Now let me describe the remaining part of the problem. What it says is that, let's look at this grid lines. So this is the y-axis. This is the y-axis, and this is the x-axis. Okay, and maybe I can do a better job at drawing the x-axis. So let me do a better job at drawing the x-axis. So yeah, so we have the x-axis. Now if you are allowed to go only up or down, left or right, if you are allowed to go only up or down, left or right, then the way you do this is like this. The one way to do this is like this. You go 2 steps down, 1, 2. You go 2 steps down, then you go 1, 2, 3 steps right, correct? And then you can go another 3 steps right, 1, 2, 3, and then you can go 2 steps down, right? So this is a path. The length of this path is 10. The length of this path is 10, right? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got 10 steps. So definitely the length of this path is 10. Of course, this is not a unique path. There are multiple paths to go from A to B. There are multiple paths to go from A to B. This is just one such path. And this is the shortest path. Now the problem says that the length of path is less than equal to 14. That's given to us, right? The length of path is less than equal to 14. So that means you can go more than 10. The length of the path can be more than 10. You are allowed to go, you are allowed to wander a little bit around. That's fine. So I will show you another path whose length is more than 10. It's possible to draw paths whose length is more than 10. I'm assuming some people here are seeing the taxicab metric for the first time. So it takes a little time to familiarize with it. You cannot go diagonally, remember? So let me draw a path whose length is more than 10. So I go 1 step right, 2 steps right. I go 1 step up, 1 step right, 1 step down. And then I could probably just complete the entire path like this. So this is the final destination B. So what is the length of this path? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you might wonder that why did the path length become 12? Because this up that we went, this was unnecessary. So to compensate for that, we had to come down, right? So we added the 2-unit length for that reason. So that's why the length of the path became 12 in this case. Now, the problem says that we are allowed to go up to the length of 14. Okay. Now, here is the question. The question is, how many lattice points, that is points with integer coordinates, the bug may visit? So how many points with integer coordinates, so those are sometimes called lattice points, will be included in at least one of the paths, will be included in at least one path from A to B. And given the condition that the length of the path is less than equal to 14. Okay. So I am saying that Sai Patil is saying, Sai is our student, I think. Yes. Sai is saying the answer is 99. Anyone else has an idea for the answer? Maybe Arjun, what answer did you get? Shaurodev, did you get any answer for this
Uh,
question?
in the exam, I had actually skipped this question. I didn't write.
Sir, actually, I told the mistake that I took point to be
Right, right.
different, but the answer Srijit sir has given is 87 on the WhatsApp group.
That is right. Uh, the answer, okay, so since we are solving these problems in a rush, we can make mistakes, so it is okay to point those out in the chat. We think that the correct answer is 87. Now, I will explain why that answer is true. Okay. So, what we are going to do, and this is very simple, we are going to take the extreme case. It's a common method of solving problems in Math Olympiad. We take the extreme case. Pranav, you can go to cheenta.com to find out about our courses. I cannot say more about it now because we're discussing the problems, but you can always go to cheenta.com to find about the programs. Okay. All right. So we will look at the extreme cases. That is, when can we achieve the length of 14? When is the path of length 14 can be achieved? So I'll go to a new slide and I'll show you how we can achieve the length of 14 so that we all understand this. You see, this is the point which is negative 3 comma 2, and this is the point which is 2 comma 3 comma negative 2. And let me draw the x-axis and y-axis one more time. So, and the picture is really horrible, but I'll just fix it, make it a little bit better. I'm sure most of you can draw better pictures than I'm drawing. So let me do it here. Okay, 3 comma negative 2. So I will be drawing a path whose length is 14. I will be drawing a path whose length is 14. So this is how I'm going to draw it. I will use this different color to draw this path. So what I'll do is I will go to the left 2 steps. Okay. So this is 2 steps to the left, and then I will come back those 2 steps. So now I have added 4 steps, right? I've added 4 steps, and now I can go from A to B. Now I can go from A to B in the remaining 10 steps. Remember, the shortest path was 10 units long. 10 unit long, right? So the path from A to B is 10, and I have added 4 here. So 10 plus 4 is 14. So the path that we are going to draw after taking this extra our little left side wandering is certainly, no, we have not discussed 26 already. This is just the first problem we are discussing, okay? All right. So this is the path of 14. So you will soon realize that you have to take a grid which is sort of two. Okay, maybe I can use the eraser a little bit. You have to take a larger grid which is 2 units up than this one. And the same thing will happen. So let me make the smaller rectangle first. Okay. So this is the smaller rectangle. And we make a room for this extra dots here to the left. And the same thing we do with those extra dots to the right. Because you see, we can do the same thing after traveling up to this point. After traveling up to this point, starting from here, if we travel up to here, then we can make that wandering, extra wanderings. We can go like this as well. We can go, I mean, there are certain things we cannot do, but of course, I'll come to that in a moment. Okay. So I will add some extra dots to each of the corners. Precisely 2 units to the left, 2 units to the bottom, and I'll fill up this entire thing. So you will realize that all the places that we can go includes all these dots minus some dots. Okay, so what are the dots we cannot go to? Okay, so we first, let's count all the dots in here. Okay, so this point's coordinate will be -5, 4. Why? Because I went 2 units to the left, I went 2 units to the left and 2 units to the to up. So from -3, 2, I went to -3, 4, 5, 4, and here this is 5, -4. So in total, there are 99 dots in this grid. There are 11 vertical lines and 9 horizontal lines. 11 vertical lines and 9 horizontal lines. So there are total 99 dots in this particular grid. But there are certain points we will need to avoid because there are certain points we cannot go to. Now, what are those points? Well, you can easily check. We don't have enough time to discuss it in full detail, but you can actually check this, that these 3 points we cannot go to. These 3 points we cannot go to. Because once we go there, our length of the path becomes more than 14. So from each corner, we cannot go to these 3 points. So there are 12 points which we cannot go to from this 99 points. So subtract that to get 87 as the final answer. Okay, so that's what we have. Now I will let someone else to go and solve another problem. So
Why are you concerned with only the corner points?
we are actually concerned because actually these points are also included, right? I mean,
Yes.
so that's why I did 9. I mean, I did not draw these points, but yeah, sure, we have to actually draw these points as well. But we counted them because we did 19. We did 11 times 9, right? When we did 11
Yes.
times 9, all the points on the vertical lines, on those 11 vertical lines,
Hmm.
times all the points on these 9 horizontal lines, all of them are counted. I just
Yes.
drew them on a block to, I mean, maybe I can
So
draw.
the idea is you can reach every point in that box, and
Exactly.
when you go outside,
Uh-huh.
you'll have to make room. Like you cannot
Right.
go too far away.
You cannot go too far away. Exactly.
Yes.
Yeah.
So every point in this box can be reached. Every point in this box can be reached in this big box, the larger box, as Shankadeep points
Yeah.
out, um, except for the 3 corner points that we just, I
Sir,
mean,
actually, we can solve this question by another way. That's a lengthier one, but
okay,
we
what is
like the
it?
ways that for any point p comma q, the shortest distance from the point -3 comma 2 would be modulus of, like I'm talking about lattice points only, mod of
Okay,
p plus 3 plus mod of q minus 2.
okay. I
And
mean,
similarly for the other point, this is a bit lengthier method, but we can do this if we have
yeah,
no idea.
yeah. I understand. A more algebraic way of attempting this
Yeah,
problem. That's good, Arjun. That's good. We can
but
probably
I
do that.
think this was a much more elegant one because like this is very simple. Like
This is, yeah, this is kind of, yeah, more geometric in nature. Okay. So Shankadeep, what problem should we discuss next? Do you have any problem in mind?
actually, I have a
Uh,
solution for 26, and someone on the chat was also saying, so maybe we can discuss
Okay,
that.
okay, that's fine.
okay,
Arjun, go
let's
ahead
go
and give us
26.
tell us what you think about 26. Let's go to the new slide and you can probably go there. Yeah. Third one. Okay.
Sir, the Jamboard is loading. Till the time I can tell you, you can draw. First, like we will call the like does everyone know the question? Like
Okay, let me
question.
give the let me put the question on the board. Maybe that is going to help you. So in problem number 26 here is there is a figure in the problem 26. So I'll just first write this down. Okay. So put a sticky note here. Okay. So here is the question in some sense, uh, and I'll also put the figure here so that we understand. So there is a picture that we want to add. So let me just go ahead and add the image. Um, 1 second. Okay, so here is the image. Okay, so we have the image
Uh,
here. Yeah.
yeah. So basically, the question is asking like we have suppose like the three colors. A suppose we have a like I'm renaming the colors just for our simplicity. A1, A2,
Okay.
B1, B2, and C1, C2.
Okay.
C1 and C2. Now consider these 3 points, these three circles.
Okay. First, let me understand the question. So, four of the six discs are to be colored black and two are to be colored white. So, two coloring that can be obtained from one another by a rotation or a reflection of the entire figure are considered to be the same. So, if you can rotate a figure and get the other one, then they are same. They're considered same. Or if you can reflect and get the same thing, they're considered same. So, what is the question now?
Sir, actually, the question is that they are showing this when we need to color four of them black and two of them white. Now they are
Uh-huh.
asking what will be the answer when we color two of them black, two of them white, and two of them blue, like three
Okay.
distinct colors.
Okay. So now, okay. So there are four such colorings. This is an example. If you are allowed to use only black and white, if you are allowed to use only black and white, so this is okay. Let me write that. If you're allowed to use only black and white and four black and two white, then up to rotation and reflection, only four of these colorings are possible. When I say up to rotation and reflection, I mean that if you rotate one of them, you will not get the other one here. Okay. So there are four colorings possible. This is an example. So the question gave an example, of course. Now, now the actual question is, if you have two black, two white, and two blue, how many such colorings are possible up to rotation and reflection? Okay, go ahead.
Uh,
That's
yes.
how they do.
So, sir, actually, there are two cases. The case one is that, first thing we know that among these three corners, either it will happen that two are of the same color, and the third one is other, or all three are of distinct colors.
Uh-huh.
So, first case you will consider all distinct, all are of the distinct colors.
Okay.
Now because of symmetric rotation and thing without loss of generality, let's fix some colors like because we can rotate and those
Yeah, we
things.
can do
So
this.
uh, so
Okay, so you
now
are
but now
focusing on the three top one, two, three of the corner blocks, and you're saying
yeah,
all three of them are of the different color. Okay, fine.
no, this is case one. I will consider the case two also.
Okay, okay. This is the
Now
case one. Okay.
after this what we will do is now these three are uniquely determined. Like this is between A1 and B1, this is between A1 and C1, and C1 and B1. So now if even if we after fix we do rotations and reflection, all will be different.
Okay.
So
Okay.
now we can fix these three other ones in three factorial ways here.
Okay.
So here in this case we get six cases, like six ways.
Six ways. Okay. So once you
See,
fix A, B, and C, you can, of course, so since this is up to rotation, we can say, okay, this is A, this is B, this is C. That's fine. Now, now all three of the internal ones will give distinct colorings. Okay.
uh,
So, but will they be distinct up to reflection?
of course, because they are like it is like everyone is uniquely determined. Like one is between A and B, one is
Right.
between B and C, and like so they are
Right,
like
right. So there will be six of them.
yeah.
A, B,
Mhm.
C, B, C, A, B, C, A, B, C, and like this. I understand.
Yeah.
Yeah, of
The
course.
main thing is that after reflection and rotation, the neighbors are preserved. So if they
The
are
neighbors.
like
Okay.
now, I moved to Jamboard 4, so can you also go there
Yeah,
because
yeah,
there
of
is
course.
no space there.
Absolutely. Let's go to Jamboard 4.
Sir, actually, I haven't done my lunch till now, so I have to go right now.
Yeah, yeah, sure, sure, sure.
Okay.
So this is number two. When two of them are distinct, two are of the same color and the third one is of the other.
Okay,
Now among the colors also there is some kind of fight. One will come two times, one will come one times, and one will come zero times. So for
okay,
this selection, we have three factorial equal to six ways.
okay,
Now let's consider any one of the six. Others will be similar. Now because of that reflection thing, I am fixing them in any order. They are one and the same by reflection and rotation.
okay. So you are saying that the second case is the two of the vertices will have the same color. Of course, that's the only other case, right?
Yeah,
So, so let's suppose that these two vertices have the same color, because it doesn't matter, right? You can just
yeah,
rotate it and get it. So if these two vertices have the same color, again, it doesn't matter which one is A1 and which one is A2, because by reflection, they will be the same. So I'll just say both are A's, maybe. Okay,
yeah.
fine.
I did a mistake. We need to do A's because blacks are similar and they do
Yeah,
not have
yeah.
distinctness. So,
Okay. And now the question is what is this one? Okay, it can be either B or blue, or it can be either black. Okay. So
for
either
that, we'll
black or
multiply by
blue.
6 into something.
Okay, so once you fix this one, there are two choices for this spot, and there are three choices for this spot. So six of them. Then what happens to the
Yeah.
internal block?
Now let's consider the block B, the other B. Let's consider the other B block. Uh,
Okay.
like uh, Either it will come between these two A neighbors or it will come between A or B neighbors. Either
It
it will
doesn't
come
matter
between
because yeah,
A.
we can do it by reflection. Right.
Yeah,
Perfect.
yeah. So and after that the C's will fix automatically.
C's will automatically be fixed. So there are two choices really
So 12
for
here.
the non-repeated one. Yeah. So this is the non-repeated color, right?
Uh, no, this is the
I mean non-repeated color
yeah, yeah,
of the outer
non-repeated.
vertex. Outer vertex. Right. So that's very good. So there are 12 cases like that. Okay.
So
Excellent.
total we get 18. 6 of that, 6, 12 of that, 18.
Okay, this looks good to me, but if someone else got a different answer, we would be happy to hear that. Okay, so next one.
Sir, actually 29th one was pretty clear, so maybe we can complete that quickly. Like,
Okay,
uh,
okay, okay.
mm,
So if you have the solution of 21 as well, 29, sorry.
yeah, 29.
Okay, let's go and try 29 then.
Sir, actually,
Shankar,
the
what do you
one
think about
thing
the
to
previous
know.
problem? Do you think it's okay, Shankardeep? The one that he did?
Looks fine. Looks fine, but with such
Yeah,
problems, I'm always in
yeah,
doubt. So yeah,
yeah. I'm kind of scared because
yeah,
coloring
I'm
problems have
always
been
scared about those problems.
yeah. So we have to see. We think that the answer is 18. This is problem. Now we start with problem number 29. So I'll again give the statement of the problem for those who are just coming in. We are solving problems from IOQM 2021, and this is problem number 29, which says that there are positive integers a, b, and c satisfying ab by a minus b equal to c. So it's given that okay, it's given that ab by a minus b is equal to c. A, B, C are integers. Okay. Uh, in fact, they're given to be, I think they're given to be positive integers. Yes. What is
Yeah,
the
positive.
largest value of a plus b plus c not exceeding 99? So largest value of a plus b plus c not exceeding 99. That's what we want to find out. What could be the largest value of a plus b plus c not exceeding 99? Okay, so looks like someone has so he, okay, so we're getting a specific answer. Arjun is saying
Sir,
that the
actually, the answer can be at most be 99. So, if we can give a arrangement for 99, that would guarantee 99. So, I have given an arrangement so that guarantees it.
okay, so yeah, that is actually good. So if you can find numbers a, b, and c such that a plus b plus c is 99, and this particular thing is satisfied, then it's actually done. So did you do this by inspection? How did you do this?
Sir, first I had to transform this equation in the form of 1 by a plus 1 by c equal to 1 by b.
Okay, so let's see what he's saying. So we will just rearrange this. This is 1 by c equals to a minus b by ab. So this is 1 by c equals to 1 by b minus 1 by a. So that gives this particular form, 1 by a plus 1 by c equals to 1 by b. Okay, that's great.
Like it was guessing only, like inspection. First,
Okay,
I
then
thought the
that's
answer could be
inspection.
95 because, like, if we take a equal to c equal to 30 and 38 and b equal to 19, but after like some more inspection, I got 99 as the sum in arrangement.
Excellent, excellent. Sure. So I just want to make a comment here. This problem, this is a problem that is similar to an AMC problem that I was just doing in a class a few days ago, and this is actually a central theme. I mean, I just
This
want to
appeared in the RMO as well a long time
disappear in
ago.
the RMO, right? Yeah,
Yeah, very
and
long time ago.
this is yeah, this is kind of weird that okay. So you see, one thing is this is a probably a bit of digression, but there is a idea related to platonic solids. You can Google this. What are platonic solids? But there are only five of them. There is a number theoretic proof that there are only five of the platonic solids out there. You can actually prove it using very basic number theory. And I just drawn two of them. There are five of them actually. Uh, and one of the steps of doing that particular problem, proving that there are only five platonic solids out there, you encounter this sort of an equation. And then you sort of bound the right hand side by some number. So the right hand side is bounded by, in this particular case, it is bounded by 1, I think, because if c is also an integer and c is less than 99, right? It's a positive integer. So the right hand side is also bounded by this 1 because it is 1 by c in this case, right? So What we do is we use this boundedness. We use this boundedness of the right hand side to estimate the values on the left hand side. So we basically use inequality to solve an equation. I mean, at the first glance, this may look like an equation with three unknowns. There are three unknowns and one equation. What are you going to do? But then what we see is that okay, we can actually bound the number of numbers that actually satisfy this, and then brute force the remaining part. So a little bit of digression, but yeah, the answer is 99. Very good. Of problem number 29. Now I go to Shankari. Shankari, do you have any particular problem in mind that we
Yes.
can discuss?
So problem number 7, I was looking at this question paper. Arjun, did you
Okay.
finally solve it? Did you eventually solve it? Problem
No,
7?
sir. I
Are
Okay.
was
you
not able to.
solve problem 7?
Uh,
Okay, let's look at problem 7 then. I will post problem 7 on the board so that uh,
okay. Do it.
people can look at the statement. So here
Actually,
is
after seeing that fraction, it seemed that it would be a very lengthy one. Like that fraction was, that fraction, how like it would that fraction. So I thought the length of BD was very different type.
Um, well, that the value of that length is not important. That should be obvious, I think.
okay. Let's look at
No,
this one.
it seemed that it would become something like a perfect square or something like that, but I got no direct idea, so we need to skip some problem in PRMO otherwise.
It's fine. It's
Okay.
fine.
So I'm in slide
Um,
7.
I will go.
Yeah, yeah. You can go ahead.
I will go to board number 7 now.
Sir, actually, Ashir is asking. I think he's on the call, and he's asking, will should he like on his camera or not?
Yeah, yeah, yeah. Please, Ashir, can you put on your
Uh,
camera and audio as well? Thank you. Okay, great. Yeah, go ahead, Shankar.
I'm on board number 8.
Road number 8. Oh, okay, okay. So, so what is the question? Maybe if we can.
The question is, you have a isosceles triangle AB equal to AC. You have a
Okay.
point B on BC such that BD. I'm not going to use the values because there is no need. So you are given the length of BD, you are given the length of DC, and you are also given the length of DE, where CE is a perpendicular onto AD. Okay, the length of CE is, say, Z. You need to find the length of AE. You need to find this. So the first observation is that this is a unique triangle.
Okay.
By that I mean, if you are given these conditions, it should be possible to solve everything about the triangle completely. Okay, so just go ahead and batch it.
So you're saying that this isosceles triangle is known to us, like
No, I'm not saying that. I'm saying that these conditions, x, y, z, perpendicular, all
ah,
this
okay,
should determine the triangle completely.
okay,
Okay. Now suppose BAD equal to theta and DAC equal to phi.
okay,
Observation number 1, sine theta by sine phi is equal to x by y. Why is that? It's because uh,
It follows
sine,
by sine rule.
yeah,
I
yeah.
it's
think.
sine rule.
You can just
It's
use the
sine rule.
area formula, I guess. Yeah.
Yeah, so we do such things in the trigonometric Sever's theorem. Okay.
Right, right, right. Yeah.
Uh, One, this is the first observation. The second observation is more angles. So this is pi by 2 minus phi. No, sorry. And this whole angle is should be pi minus theta minus phi by 2, right?
Okay.
Because
Yeah,
it's
of course.
isosceles.
Of course.
And this one here should be sine inverse z by y.
Right.
Hence, board number 9.
But sir, will the triangle be determined uniquely because first we can fix BC and point D because of the length given, but the length DE of 7 it can vary around that circle like the point E.
I think that
Mm,
I think the
no, there are
triangle.
too many conditions.
I think a triangle was uniquely determined when I was in
Oh yeah, yeah, it
physics.
will be uniquely. Sorry, I didn't see the
Uh,
perpendicular
yeah,
condition. It
there's a
will be.
perpendicular. Yes. So,
So
so
I think
now,
if
no,
we can get that picture here, that would be great, right? So,
yes,
can, do you want me to get that picture here? Just a second. I'll do it in a
sure.
second. Okay. I'll go ahead and pick up this picture and I will just paste it there. This is fun doing problems together. I
Indeed.
don't think we've done this together like this before, right? Okay. All right. Here we go. The picture is here, so you can see it. So we are basically equating this thing. Okay, got it.
So now we will take the sine. So we'll board number 10. We'll get a second equation which is z by y equal
Equal to
to
sine. Okay,
sine of uh, phi minus theta by 2.
right.
So this is equation number 2.
Okay,
And now it should be possible to solve 1 and 2 together, right?
okay. So those who forgot what is one, let me get that back for you. So this was one. Sine theta by sine phi is x by y,
Hmm.
and this is two. Sine theta by sine phi. Like this one is uh, sine theta by sine phi is equal to x by y. This
But
was
sir,
one.
the value of y should then come in use at some point. Will it
Yes,
come in?
it will, but we'll leave it at that. We'll leave it at x, y, z. And by the way, let us just check if we really need to solve all this because we just need the value of AE, right? And we might not need to do all that. Okay, so CE, I'm just checking if we really need to do all that. So still board number 11, 10,
Okay.
still board number 10. CE is root y square minus z square, and uh,
Yes, Tanish, we can do that. We can definitely try number 12. So, did any of you solve number 12 while Songkadev tries to process this? Let me ask
Mm,
that.
sir, actually, I was not able to solve it, but by seeing some other example, I think I have a reasonable guess. It's not a good logic, but it might be something like.
Okay. What is, what do you know? What do you think? for number 12?
I think the answer should be 12, but I have not solved it by some logical way. So, it's like some like tukka type of or some other method type of thing, but I have not solved it very logic, like formally.
Okay,
I
that's
actually
fine.
got what 12, question 12.
Okay, Ashir, what did you get in that?
No, no,
You
I
can.
forgot what was the question.
Oh, you forgot the
I
question.
forgot.
Okay, let me give you
Which one
the.
was it?
Actually, I've sent the PDF of the question paper on the group some time ago. I will send it now also, so that because it
Yeah,
would have
that's
gone
fine.
very far away.
I'll just pose the question here as well. So here is the question. I'll we will come back to Sean Congo. Let us know whenever you want us to come back to you. And in the meantime,
Fine.
we will just go to question number uh, 12, which
Because
Ashwin is.
in the seventh question, I think I got like equation, so I think I know how to manipulate to get
Okay,
Z
so this is the question number 12. Yeah, go ahead.
So,
value
what
as
was your
Z.
answer for 12, Ashir?
First and then. Oh, this.
Sorry,
Okay.
actually, your voice just broke down. What did you
Oh,
say?
I was saying how to manipulate, how to like I find Z in out of those two statements for the seventh question. I had some few ideas. I mean, we discuss that after this.
Okay, but did you say something about question number 12?
You hear me?
Yes. Ashi, did you say something about question number 12?
No, I just wanted to know what the question statement was. I forgot the question.
Oh, okay.
I wanted to know what the question statement was.
Uh,
Okay, okay.
should I show
I just
it?
forgot.
It was it.
Yeah, the question statement is on the board actually.
This question 12.
I can see it now.
The question statement is on the board.
Okay.
Oh. Actually, there
Oh,
was a figure
we'll
also.
do that next.
Yeah, the figure, I'll post the figure.
Yeah.
Just a second. Yeah, here is the figure. Here's the figure. Okay. So by the time you guys process that, I'll go to a easy one. And
Yes, maybe we can first complete the like easy ones which are like trivial,
yeah,
so that
the
we
easy
have.
one is the one that I was looking at. It's actually quite easy. Problem number 20 from this thing. Problem 20.
Sir, what answer did you got? Actually, I was unable to solve it completely, maybe, or like some. I had very doubt of my solution.
Okay, in problem 20, first let me give the problem. I don't remember precise answer that I got. I have to solve it one more time, I guess.
Sir, should we complete the problems like 1, 2, 3, 4, 5? They are just like one-liners,
Yeah,
or
sure.
maybe we can continue with this first, as you wish. I'm fine with anything.
Yeah, I mean,
I still think
I think these are the questions that students have doubt with. So we can come back to one, two, and all those things.
Okay.
Never mind this one. Okay. So this was the this is the question, and my answer I think is 75.
Yeah, yeah, I also got that 75.
75 is my answer. Anyone else got 75? Someone
Uh,
for I think someone from the audience can actually confirm.
Actually, I got 75, but I was very doubtful for my solution because it was solved in last minute. So it was like very fast, and so calculation mistake or like some errors were obvious. Like it might happen.
Okay, so this is the thing that if we have a group of working women working together at the same rate, can build a wall in it's probably it might be 75. We'll see. So at the same rate, can build a wall in 45 hours. When the work started, all the women did not start working together. They joined the work after a period of time, one by one, at equal intervals. Once at work, each one stayed until the work is complete. The first woman worked for 5 times as many hours as the last woman. How many hours did the first woman work? So this was the what is going on here.
Arjun, just
Okay,
back.
so this is the one, right? Okay, so we don't know how many women are working together, but they are building the wall in 45 hours, means 45 into whatever number of women are required is, suppose there are n people in this group. Now, that number of working hours are required, right? So that many working hours are required in total. Now, they did not start working together. So after the first woman joined, so the first woman stayed until the end of the work. Suppose the amount of hours that the first woman gave is F hours. And over the period of time, they joined. So after T hours, suppose the second woman joined. So the second woman worked for F minus T hours. The third woman joined for F minus 2T hours, and so on. It will go on up to F minus 3T, up to F minus N minus 1T. That is the last woman worked for F minus N minus 1T. Okay. So the first thing that we know, this is the total number of work hours, and this should be equal to 45N, right? That's 45N. Okay, so now the other condition that we are given is the first woman worked for 5 times F minus N minus 1T. So we have F is equal to 5F minus 5T times N minus 1. This is the second condition that we know. So the question is, for how many hours did the first woman work? So we can actually replace the entire thing by, we can solve for F. We can just get rid of, okay, so this is 4F is equals to 5T times N minus 1. And we can, so what can we say about T and N minus 1? Can anyone tell me that? From this equation, what is it that we can say about 4 and T? So there were some conditions which we probably will be able to impose, and we will get n is equal to 5. So I mean, you can check these can be done by some simple divisibility argument. N would be 5, and the last condition would give you 4T. And if you add all of them up and solve for F, you would get 75. T being the value of T being 15. So this was problem number 20.
Okay.
All right. So now, do we have anything, Shankadeep, from your end?
Well,
Okay.
I'm sure that these two equations that I have written down determine the triangle, describe the triangle completely.
Okay, that's fine.
But
Please come
yes,
back to us when you have the specifics.
yeah.
and then we can go
Okay,
to
fine.
Arjun and go to the first few problems for the moment. Okay.
Yeah,
Arjun,
the
Right.
first, okay, maybe just I will tell them quickly. Or maybe I can, sir, can we first go to the third one? I can just say it, and I'm like a little bit slow in writing, so you can just write the things quickly, the main things.
so I'll just put the first question here so that we understand what the first question is. Just a second.
I'm on slide number 13. I will just write it out. Oh,
Yeah.
yes, this is the third one. The first thing to notice that the denominator can be written as k plus 1 whole square into k square.
Okay. So
The
definitely.
second thing is that the numerator is k plus 1 whole square minus k square. So we get a telescopic series, like very basic one.
Okay. So this is what we have. Okay. So what do we do? Sorry.
Now we write 2k plus 1 equal to k plus 1 whole square minus k square.
Okay. 2k plus 1 is definitely k plus 1 whole square minus k square divided by k square times k plus 1 whole square. So
After
this
that, we just get this value as 1 by k square minus 1 upon k plus 1 whole square. And the value of this summation would be 1 minus 1 upon n plus 1 whole square.
this is 1 by 1 upon,
1
yes,
minus. 1 minus.
sorry, yeah, there will be a 1 in the
Now,
middle.
if we just equate, we get n equal to 99.
Excellent. So this is equal to
This is a telescopic
0.999.
series.
Yeah, so it will all cancel off and then will get us n equals to 99. That's fine.
Arjun, is 18 similar to this?
Uh, Sir, can you please repeat?
I said,
It
if is 18 similar to this?
18th
18.
question.
Yes.
Oh,
Okay,
just
I
let
think
me
you
see.
are already with us.
Yeah, 18th one is very similar. I think, yeah, it's very similar and it uses a similar, almost the same idea, but just a little bit manipulation tough, but it's same, almost like same idea,
Okay,
very
so why
similar.
don't we solve 18 then? That would be great.
Okay,
You have a
we can
solution for
move on to 18th.
18?
Yeah, I have a solution for 18th.
Okay, let's go to 18. Number 18. Is the answer 80 for 18?
Yeah, yeah, 80, 40 plus 40, 80, yeah.
Okay, so let me just add the image. So if it is too fast for some of our audience, let us know. We will be able to. So here is the question number 18. Here we go. So here is the
Yeah.
question. So we want to find out the summation of k equal to 1 to 40 square root of 1 plus 1 by k square plus 1 plus 1 by 1 plus k plus 1 whole square. And it is given to be equal to a plus b by c, where a, b, c are natural numbers and b by c is a completely reduced fraction. So that's the meaning of GCD of b by c is equal to 1. We want to find
Yeah.
out the value of a plus b. Okay, how do we go about it?
So if we just like first expand it like then the numerator would become k square plus k plus 1 whole ka square.
Okay, so just let's take the LCM.
Yeah.
And if I do that, I'll get k plus, so I'm just working with this part, this thing inside the parentheses. So k plus 1 whole square, this becomes k plus 1 whole square times k square plus k plus 1 whole square plus k square, right? Square root of that, oh, the denominator will have another k square. Okay, so this is going to be uh, k into k plus 1 because square root will work. And what would happen to the numerator?
K square plus k plus 1 whole square.
So k square plus k plus 1 whole
Okay, the
Whole
square.
square
square
is
will
10.
cancel. Then the
The
square will cancel.
square will cancel off. Okay, that's fine.
Yeah.
Okay,
Then we can write this in the form 1 plus 1 by k minus 1 upon k plus 1.
You just
so
do the
this is
partial
1
fraction
plus
decomposition.
Okay, sorry, 1
Yeah,
plus.
yeah, exact. 1 by k minus 1 upon k plus 1. No, minus 1 upon k plus 1. Yeah,
Okay. So we want the
rest is
summation of this one.
trivial.
Okay.
We can
And
take the 1 out and that would become 40, and inside the summation it would be 1 minus 1 upon 41, which is 40 by 41.
okay. So this is easy now. You add 140 times, so you get 40 out, and you can solve this as a telescopic sum. So if you have not seen telescopic summations, I think there is a very nice piece on this on Arthur Angel, telescopic summation problems, problem solving strategies. You can check that. Okay, now let's go back to the trivial. Well, the answer is 80 for this one, right? Okay,
Yeah.
so now let's go to number another easier one. I think we are almost out of time, but we cannot drag this forever. But let's see, which one do you think, Arjun, we should go to? And Ashir and Shorojit, we
Uh,
cannot
Sir,
move on.
maybe a tough one like a 5 marker, maybe 28th one.
28th
If
one. Okay, you have a solution for 28? The natural
yeah, I
number of
have a
n.
solution for 28.
Okay, is it 93 the answer? Is that correct?
Yeah, yeah, 93.
Okay, 93 is the answer of number 28. So,
The main catch was that all numbers other than 2 key powers could be returned. Like,
okay, so a natural number of number n is said to be good if n is the sum of r consecutive non-positive integers. Sorry, what is this? Is a, I think there is a typo here. R consecutive non
No,
consecutive positive integers. Sorry, R positive consecutive positive integers for some r greater than equal to 2. So let's look at this one. So n is equal to so if k is the first one of them, k
so
is
then we get the simplified form as 2, like n is equal to 2k plus r minus 1 into r by 2.
okay. So just to make sure what we are looking at, a natural number n is said to be good if n is the sum of r consecutive positive integers, where r is greater than or equal to 2. So basically, I'm saying that, okay, let the first number be k, and the second number is k plus 1, because we are looking at consecutive numbers, up to k plus r minus 1, right? So this is, if we add them up, what do we get? Well, we'll get r times k plus 1 plus 2
Um,
plus r minus 1. So this is the
yeah.
triangular number summation formula. So this is r into r minus 1 by 2. Rk plus r into r minus 1 by 2. Okay, this is the value of n. Okay, now what do we do?
No, we
yeah.
write the we to get the like solution. We write n in like we simplify this, not simplify, but cross multiply r
Okay,
into 2k plus r minus 1 by 2.
okay.
I
So r into 2k plus r minus 1 by 2. That's the value of n.
Yeah. Uh, Ashi, did you want to say something?
no, I just wanted to. What I did was I actually put made it to go to the elector so that everything becomes like is figured out with, so that like we are actually I'm basically
Okay.
I made it to the elector. It becomes neater actually.
So one thing to notice that all what we are doing is like if and only if. So so this is if and only if condition. So we need not verify in the end.
Uh-huh.
Uh,
So
uh,
we are excluding only the, so every number can be written like this except the powers of 2. Is
of
that what you
two.
think?
Yeah.
Yeah. So
But to prove this, what we will do is now we will write 2n equal to r dot like that thing. 2n equal to.
Okay, 2n is equals to r times 2k plus r minus 1. So if, okay,
Yeah. From here, what we will observe, first thing was given, that is r is greater than equal to 2. So basically, the thing on the RHS is a product of a even number, a product of a odd number, both of which are greater than equal to 2, and it's also if and only if statement. Like the LHS can be written as a product of a even number and a odd number, both of which are greater than equal to 2.
right.
Like so like if n has something odd, then we can write it. Yeah, sure.
Oh,
I
okay,
was
let's see.
just saying, yeah. So like this question has a necessity and a sufficient condition. So basically, we need to prove that it's necessary that the power of two, like it
No, but I
cannot
said
be a good
previously that
number, and it's
what
sufficient
we are doing
if you're
is if
not.
and only if.
Yeah.
So
So what
if
I was saying,
n,
um,
sorry, so if n
oh
is a
yeah.
power of
So what I was saying
2,
is,
then it breaks down, right?
Yeah. But if
yeah.
it is not a power of 2, then 2n can be written as a product of a even and a odd number, both of which are greater than equal to 2. And LHS also can be, oh sorry, RHS also can be presented like that. So we
So
just need
just to
to,
make sure that we are all on the same page as Arjun, if R is, so we have to look at this right hand side a little bit more carefully. I'll just zoom in a little bit here. So you see, if R is there, if R is odd, if R is odd, then this is even, and this part is odd minus 1. So that's even. So this total thing is even. So what Arjun is saying that the right hand side is always odd times even.
which are
So there
greater
is
than equal to 2.
and it's greater than equal to 2. This is greater than equal to 2.
That means it
And
has.
what if R, what is R if R is
But if
even? If R is even, if R is even, what happens? Maybe I can change the color of the pen so that we, oops, sorry. So this is, we, it'll be a little bit easier to understand the difference. So the other case is when R is even, let's delete this. It's even. So this is already even, but this is even minus 1, which is odd, right? So even plus odd, this part becomes odd, greater than equal to 2. Okay, so at any rate, the right hand side is odd times even, where the odd number is greater than or equal to 2.
thus
So
it has an odd
certainly
prime factor.
n has to have a odd prime factor, odd factor.
Yeah. This is what I was trying to
And
say
this is
ultimately.
also if and only if
This is also an
You
even
know,
only if statement.
this
But we have to,
actually you can't. Oh yeah,
yeah,
you.
sorry.
Yeah, because this is also fine because if I want to find an n such that this condition holds, basically,
Right.
if you want to prove that if n is not a power of 2 and we want to find r in case such that this equation holds, then we can, what Arjun is saying is if and only if, because we find such an r in case. Like basically, what we can, so like,
yeah,
for example, let's say n is 7. So if n equals 7, for example, we'll get
Right.
that
then
2
3
times
plus
7
4.
is
Yeah,
14.
3 plus 4.
So,
So
Uh,
what Arthur is saying is that can you reverse engineer this particular
yeah,
formula and say, okay, if n is something, so what do we have? We have 2n is equal to r times 2k plus r minus 1, right? That's what we have. So what actually is saying, okay, suppose n is odd, so maybe I mean I'm sorry, if n is not a power of 2, then do you have a way of figuring out r and
yeah.
k?
Sir,
Okay,
the ways that basically we can write it into even into odd. The first observation is that Now, if the even part is smaller, then we would take R to be even, and if the odd part is smaller, and we will take R to be odd. The main thing is that like 2k minus 1 varies over all positive integers. So the even odd thing can be like k will do that.
Yeah,
Uh,
Ah,
yeah.
so
So
by
this
yeah,
the
is
way,
I think, yeah, I
by the way,
think this.
7 is ready.
Okay, that's great. So we can go back to 7 now. And before, I think there is a request for 20 30.
Yeah, yeah.
This
There
is
is
like,
a
this is very interesting. So we will just do two more problems, 30 and
so
7.
the answer of this is 93 because we will exclude the powers of 2.
7. So
yeah.
answer of this is 93. Okay, that's great.
I just want to say that
So
this step is actually important because like you have to make sure that
absolutely. This is very important, actually. You are right, Ashir. What Ashir is suggesting is that you cannot just say, okay, the left hand side n cannot be a power of 2. You have to actually show that if n is not a power of 2, in each of those cases, you can find r and k, which works. So certainly that's a very good point, I think. So all right, so we will just go ahead and go to the next one. So before we go to 30, there is a pending one for 7. 7. Do you want to show Shankodeep? Do you want to go to which board do you want me to go to? Do you want to go to a fresh board or what? Your audio is muted actually. Sorry.
Let's go to 8 where the diagram is shown. So I
Okay,
will
so let's
start
go to.
again with the diagram.
Okay. Oops. Sorry. Okay. So 8, right? Okay, so this
Hmm.
is right. Let's go to 8. Okay, here we go.
Yeah. So as I was saying before, that this
Right.
is a unique triangle. That is the main observation. Okay. So it should be actually possible to find all the variables, which in this case are theta and phi. So
Okay.
the first equation is comes from sine rule, which is by the way, BD is x, DC is y, and DE is z. I'm not using the actual values. So the first equation is sine theta by sine phi equal to x by y, and note that the angle ACE is pi by 2 minus phi, and as AB equal to AC, we must have BCE equal to phi minus theta by 2, just angle
Right.
changing.
Yeah.
So that gives us, now we'll go to board 10.
Okay.
On board 10, you will see that gives us the two main equations that we need. The first
Right.
one is the one from the sine rule, x by y equal to sine theta by sine phi. And the second one is z by y equal to sine phi minus theta by 2. Okay. Next, on board 9, we will again use sine rule. We'll again use sine rule on the triangle ADC. Okay. And that will give us AD by y equal to cos of that cos comes because it's actually pi, the angle is pi by 2 minus theta by 2 minus phi by 2, so it's cos. So it's cos theta plus phi by 2 by sine phi. Now note that 2 cos theta plus phi by 2 into sine phi minus theta by 2 equal to sine phi minus sine theta. That's product to sum formula.
Yeah, 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 exactly.
And from our second equation, we have that the second factor is z by y. And
Right.
from here, the first factor is 2AD sine phi by y.
Okay.
So
This one.
this is why it took so long, because I made a calculation mistake.
Uh-huh.
It's actually sine phi minus sine theta. Yeah.
Okay.
Now this gives us AD equal to y square into sine phi minus sine theta by 2z sine phi. Now if you divide by sine phi, you will get, this thing becomes 1,
Uh-huh.
and the second thing becomes sine theta by sine phi, for which
Which
you
is
have a formula,
right.
which is
Why? Yeah.
actually what? which is x by y.
X by Y. Yeah.
So all the angles are eliminated.
So okay,
We
so
have
just
found the length of AD,
so
and
A
if we
is
subtract
equal to Y square by 2Z times 1 minus X by
x
Y.
by y,
Okay.
and if we subtract z, we will get AE.
So to get AE, we just subtract from this thing Z.
Yes.
Okay. Looks kind of a complicated expression, but this looks very nice. This is
I mean, like most students will be like most people giving the exam will be doing it with numbers. So like over here you're getting like a
Hello.
rational function, but like you just
Yeah,
it'll be
actually, I
simpler.
also left the problem
Hello.
yeah. I
like it.
think the numbers were there to confuse you guys, I guess. So
Yeah, the numbers were there to confuse you.
Hello.
yeah,
Hello.
yeah, yeah.
No.
Yes, sir.
So
Can you
one,
hear me?
yeah. Who is this?
Srijit.
Sridhar,
Srijit.
sir.
Oh, Srijit is here. Where is Srijit? Oh,
Okay.
Srijit is
So,
here. Okay, if
so
Srijit is here, then I am going to leave. But I
not like
will
that.
at the very end of this.
No,
So
actually, I have a different idea on this problem, so I want to share that. If
oh,
I mean,
that's
that's
great.
fine.
Srijit, do you have the Jamboard?
Yeah, I have the Jamboard.
Are you in the Jamboard? Okay.
Yeah. So I'm just not sure. So let me go to that. Let me go to that corresponding.
Which board do you want me to go?
The that board like where the diagram of this problem 7 is given.
Okay, board number 8. I'm there.
Yeah,
Okay.
so just let me go over there. Board number 8. So here, what I think is that can I draw this? I think I can draw this here. So
Yeah,
can you
yeah.
go to
Sure.
number 7?
Board
So
number 7. Okay. Let's go to board number 7. 7. Okay.
so
Yeah,
these two
sure.
are equal. So what I have done, I will just share. I don't know why I am not being able to zoom it. I mean, is it
You
possible
don't
to?
have to. I'm zooming it. Don't worry. Because even if you zoom it, they can't see it. They can see only my share.
Okay, so what I'm trying to do is I use similarity. Okay, uh,
Okay.
so it's A, D, B, and C over here, and if I draw perpendicular over here, okay. So and if I draw perpendicular over here,
Uh
so
huh.
let's call it E and F. So we know this value X, we know this value Y, we know this value Z. Okay, and we know this
Right.
value that is root over Y square minus Z square.
Uh
Hmm.
Okay,
huh.
so from this we can know this BF value. Okay, and this value, both this because these two are similar.
Yeah.
Right.
So therefore we know this triangle and we know this triangle. Okay, so that's what we know here. So let's call this lambda. So what I'm going to do is that, and let's call this h. What I'm going to do is here is half into h into this length y say is same as half into this bf which we already know calculated into this length, that is uh, let's call this df plus this z plus this lambda. Okay, so now again see this triangle and this triangle are similar, so we'll get
Sir,
a.
unable to understand this. How you got
Okay,
this equation half into h into y, this
So
one
thing.
he
second.
wants to prove this. He will prove this.
No, I mean I think the diagram is creating a mess. Do you have a better diagram like drawn
A
or
better
No.
diagram drawn. I can probably draw a better diagram here. Let me see.
okay?
We
Can you
can
draw
draw
that whole?
using those lines, maybe like the
There is no line
tools.
over here. That's the problem. Anyways, let's try to understand this. So,
Okay, I'll
so
create a better diagram in the meantime. Maybe that will help.
yeah, sure. I'm drawing this perpendicular. Okay, let's call this y. Let's call this sorry. Let's call this z. Let's call this y. Let's call the height h, and let's call this what we are required to find lambda. Okay, and this is x, and we have drawn a perpendicular here. So what we are trying to do is that we know this bf, you know, because these two triangles are similar. Which two triangles are similar? This triangle, oops, this triangle and this triangle are similar. Okay, and we know this side we know corresponding this side we know is corresponding side is this side x. Corresponding to this side it is I think it is this, and corresponding to this green side I think this is this. So we can, since we know a is a y, z, and this, and we know one of the values x, we can know this perpendicular here, and we know can know this place, this both this green and both this blue, okay, and it will be like in numbers. So now idea is if we call this lambda, what we will do is that we will compare the area of A, B, and C, triangle ADC, in two different ways. Okay, one way we will do it half into height, this height, into y. Another way we will do it is half into this BF, which we already know, this green one, times this DF plus Z plus lambda.
सर
So
इंटू बी एफ के आगे क्या है?
half.
तो
This
बी
one.
डी एफ का एरिया तो बी डी एफ का एरिया है ना, इससे तो हाफ इंटू बी एफ इंटू डी एफ से तो शायद
I think
I'm so
area
sorry. I'm so sorry. I'm so sorry. Not
square
this. Not this one. Not this one. Not this one. I'm so sorry. This will be
square.
half into root over y square into z square
No,
times lambda plus z. Okay. Sorry for this. So half into h into y is equal to half into root over y square minus z square is into lambda plus z. Did you get this one, Arjun?
यस
yeah,
सर.
So now we have a unknown lambda here. What we will do, we will find h in terms of lambda. How will we do that? Observe again that this triangle, I will, this triangle and this triangle are again similar. So, and we know this triangle now, and therefore since we know this side in terms of lambda, we can get h in terms of lambda again. So therefore, this will be a linear equation in lambda. You can follow lambda to find h. Yeah, I think this is a better diagram. Yeah. So what I will do now is that this is h, and this is x, this is z, and this is y. Okay. So I will, two observations are there. One is triangle A D G is similar to triangle B D and F. Okay. And second observation is triangle BD, which is also similar to, triangle DEC. Okay. So now observe the triangle DEC is entirely known. Triangle DEC is entirely known. Okay. Because this is root over, this EC is equal to root over y square minus z square. I hope you get this, all of you getting this. Did you
Yeah.
get this point, guys?
Yes.
This one,
yeah,
all of
yeah.
them are similar.
Sir, just let me see it once. I think like why they are.
This is 90 degree and both the vertical angles are equal. So two angles are equal. So just check this
Oh yeah,
once.
yeah.
Okay, so therefore we get this, these two triangles are similar. So now total angle D, the triangle DEC is entirely known in terms of YZ and root over y square minus z square. This one, right? So now we know one of the sides of BD. So therefore from that we can know BD, we know a BF by similarity, and we know DF. Okay. So we know these three sides by this similarity. All of you, did you get this point, guys?
Yeah.
Yes.
Yes or no?
Yeah,
Asim?
yeah, I think I
Yeah.
understand what's going on.
Sir,
Okay.
wouldn't it all be very lengthy? Like even if we
No,
succeed.
I mean essentially it will be numbers instead of x, y, z. So it will be just computation over there. And what I am trying to say is that if you compare the area of triangle ADC, so it will get half into h into what I have seen is y is equal to half into this side EC, that is root over y square minus z square, into this z plus lambda. So what we have to just show that since ADC is ADG is similar to triangle BDF, and we know entirely triangle BDF, and one side AD is in terms of lambda plus z. Okay, so therefore this h will be also in terms of lambda by similarity. So we can get h in terms of lambda. Lambda plus some lambda का linear equation होगा. And therefore from this equation we can get an entire linear equation in lambda, which will give the result, I think.
So
Yeah.
Does it make sense, guys?
Yeah, I think
सर ऐसे मेरे हिसाब से आ तो जाएगा, लेकिन जो बीच में कंप्यूटेशन होंगी ना वो मतलब जैसे बीडी की जो लेंथ है ना वो बहुत अजीब है, मतलब तो शायद बहुत
किसका लेंथ,
दिक्कत आएगी। बीडी का लेंथ
I
बहुत
think
ही
it's
अजीब
given
सा।
just to make sure that, I mean, I don't know, like I think don't think the calculations will be bad. I personally don't think so. Let's see. I mean,
ओके
something to put अच्छा. See, I mean,
एक्चुअली
BC is equal to 61. This is this. I think something will cut out. I think BD by DC, BD into DC will come somewhere. I think.
सो सर
Anyways,
व्हाट डिड यू गॉट द फाइनल आंसर एज?
I
the
think
solution.
yeah, the final answer, the solution. I think the this is just the method of proof. I don't think the number is. Sri, did you? I don't think you have the number, right?
I just joined and I just like poured in my
ओके
ideas. I'm
Yeah,
not sure.
I have an expression, so you can substitute there if you want.
Sure.
Yeah.
দেখাও শঙ্খদীপদা।
Okay, so we have two types of solutions for this one by similarity, another one by
Actually, sir, I have a very
Trigonometry.
direct type of solution, but it also kind of like a bashing type of thing. Not
So let me
bashing, but
just find
calculation.
out the solution. Uh, can you just tell me what? Okay, I'm just seeing it. Okay, you carry on your discussion. I will
So,
just
Okay.
prepare it.
it's
So I
on
think
board
this
9.
is getting a bit longer than we planned. It's
Yeah.
1.5 hours already. So what we will do is we will be post. We are already posting solutions and discussions in our website in the link that I just posted, and all the solutions are also posted there. Will be posted there. They're getting posted already, so you can try to look into that tomorrow or day after tomorrow for more updated stuff. In the meantime, if you have more ideas, you can all obviously correct us. That's fine. We may make mistakes. We can make mistakes. So please let us know if you think you have a better solution of something. You can put a comment there, okay? And I'll just say thank you to Shankodeep, Srijit, Ashir, and Arjun, and Shaurodeep, and everyone who joined today. This has been fantastic. We should do this sometimes, like with some other problems. Maybe this is just a very good problem solving kind of session.
Sure. I
Uh,
think you have done
Yeah,
a similar
we
session with Pankotip before.
yeah,
yes,
yeah.
You have done
we do all the time. Do this all the time in level 5. So you're welcome to visit us.
Oh, really? I don't see that. Are you posted in YouTube as well? I don't see that.
No. But that's
Okay.
all that we do. So the problems I give are usually unknown to me.
Oh,
So
okay, okay.
we,
That's awesome.
yeah,
Yeah.
we solve them together.
What's better than unknown problems? All right. Thank you, everyone, for joining out.
thank you.
And
Yeah.
I'll just stop the session here. I'll see you guys in class or sometimes later. Take care. Bye. Take care. Thank you, everyone. Bye.
Bye.
Bye,